Okay. David Fields wrote the talk, and I'm giving the talk. David can't be here, and I probably learned a lot more than David has in the last 3 weeks. That I have had this board for 3 weeks or thereabouts in my hands, and I've been able to play with it and learn. And David doesn't have one because we only got one. Which leads me to the first thing. How did we get one? We got one because we're nice guys and we talked them into it. We saw that what's called Lime SDR came on the market, and they broadcasted to everybody that said that they're going to do crowdfunding for it, and then you can get your chance to get a deal on an SDR board or an SDR system. And David and I both didn't think it fast enough and didn't get the early birds, so we got the second flock, they call it, of early birds. So we bought in at $249 a piece. After we got it in, I said to David, what do you think if I ask the guy, Abraham, I don't know if I can pronounce it, anyway, Abraham, in Lyme, whether we could get an early delivery of one of the boards. So we set up a conference call with him. He says, not only will I give you an early delivery, I'll send you one next Tuesday. Oh, okay. That's very nice of you. So David couldn't be on the call, and David later said, can you send the second one? He says, no. don't have, they're all committed. But for SARA and for the people involved in radio astronomy and the ham radio community, we want to get it out and have it seen and tried and write software for it, and they want us to be a beta user, basically, which is what we are. Okay, arrows down. Last year, we did this, talked about RASDAR 2 a little bit, and set up a loan program and had loaners running around. And that's what we had in software. It's called FFT, or RASDAR Viewer, modified FFT Viewer from Lyme. Okay. That's what the control looked like. You could set up things to record the disk if you wanted to. And it had most of the things you'd want to have as a radio astronomy user. Now, RASDAR 3, Bogdan isn't in here right now, but he's the main proponent of RASDAR 3, and I guess he's not going to give a talk. I was going to say listen to his talk when he's going to go on, but I don't believe he's going to. But he added some features to it. We had difficulty getting RASDAR 2 manufactured because it cost too much, so we cut some cost out by removing components we didn't need, like the second FX3 chip and the second interfaces for the outside world. And so it was a slimmed down version of RASDAR 2 with some added features like expansion boards, which were kind of nice. They'd be nice to have, like a GPS interface. And but it was still out of control on cost and out of control on delivery time, is my best. And my judge back there can say, am I right? Is it out of control on cost and delivery time? Yes, sir. Yes, sir. Right? He did a whole study of it. You're going to hear about later how it's out of control. So we kind of said, if we got an opportunity with Lyme, let's take it. And Bogdan's coming around a bit, but he still wants to pursue RASDAR 2 or RASDAR 3. So if you really want to see some of those features, like a hat on a Raspberry Pi board that he's built into it, or GPS, where you could take a GPS hat and plug it in, it was used on Raspberry Pi. We might do that, but he doesn't really have it done, so it's not ready and available. So we're going to kind of go on to 4. Unless something else happens. Okay. Going beyond it. Lyme SDR is the core. It's a LMS 7002 base board, which has 2 channels, wider bandwidth, wider frequency range, no need for an up converter. 61.44 megasamples per second, which gets you into that much bandwidth. has a TSP on chip. TSP I want to talk about because it's a secret little feature that we guys in radio astronomy might like that everybody else doesn't know about. Right? TSP stands for Transceiver Signal Processor. If you came from the telephone business, in the 1970s or thereabouts, we introduced what we call DSPs, Digital Signal Processors. And they did things like, did echo canceling on every circuit. Right? They did things like adjusting levels, like somebody mentioned new law compandering earlier today. They did new law compandering, right? Because all they did was A to D convert and then D to A on the other end. And in between you did digital signal processing of playing with the bits and doing the things you wanted to do. But they couldn't do it very fast. The highest we were doing at it was 1.5 megabits, maybe 6 megabits later, or 30, 40 maybe, 45 I think he probably got to eventually. But initially it was the right concept, but the chips weren't there to do the high speed. This has the high speed. They're doing 60 megabits per second, parallel processing, 2 channels transmit, 2 channels receive, right? All in a DSP, right? That's the feature. Now what does it mean for radio astronomy? I'll show you a little bit later, but we take bandwidth and convert it into system sensitivity. If you trade off, you get the noise reduction by using the bandwidth. Even though you don't need it for a spectrum plot. But if you trade it off, you can get rid of the noise, reduce the noise. Anyway, there's what we already talked about it. There's the boards, front and back. 12-layer board, I think. I haven't really seen it officially in writing, but that's what the rumor is on the wiki that they have on the system. Is people wondering about the 12-layer board, right? And I don't know whether they published it, but it's multi-layer, I'll say that. And you can see it from there. There's some of the ground plane showing through on different places. There's a ground plane all the way around the outside, on the edge, which in those boxes that are passing around, those are slotted, and one side slides right into that ground plane. On the other side, there's 2 standoffs, which, because we're using a 2.5-inch board and a 2.5-inch box and a 60-millimeter board, they didn't quite fit. But the easiest way is to put 2 standoffs in, and one side's in the slot, and the other's on standoffs. Cheaper. That's the whole theme of this, is to reduce the cost.
Oh, before you explain the chip and all the connections around it, they may not know.
Oh, okay, yeah. Where's that pointer somebody had here? This must be it. Go pointer. There it is. Okay. Up on this end is the analog interface end. This is the line chip. This is the FPGA. That's the FX3 USB interface chip. The rest of them are incidental stuff like power and other stuff. But each one of these ports, these are all UFL type connectors, or MCX somebody said, I think is another name for it. They're what you're seeing inside computers now for the 2.4 Wi-Fi connection to the outside world. And tonight I'll take the cover off one of those and show you the inside, or we can do it out in the hall, but I didn't want to lose the screws right here. They're tiny screws. But each of those, there's, like I said, there's 7 UFL connectors in there. And I think this is the receive side. I think this is the transmit. Yeah, there's 4 on this side, so this will be the transmit side. And this is the receive side. So there's 3 and 3 different connectors of the receive side. And up there is the 10 megahertz reference input. And right next to it, for future use, is a GPIO interface. It's a header, a 10-pin header, in a little tiny half-size header, right? 1.27 millimeter spacing pitch. And I was able to find on the web a ribbon cable that will fit on it with 2 connectors on each end. So when we come back later and put in an expansion board, if we want to do GPIO type controls, we'll probably just use that ribbon cable to go between the boards. And you layer another board on top that has interfaces to the outside world of controlling relays and whatever else you want to put out there. Because I don't really think we ought to send the FPGA leads out to the outside world up your antenna. Right? Right? But you might want to do antenna switching with it outside world. Okay. Any other questions on that? Is that good enough for?
Where's the TSP or DSP?
It's right in here.
Oh, it's built into the.
It's right on that chip.
Okay.
Okay. They do this A to D, sampling, and they process those bits in parallel. And then they clock them out to the FPGA and then clock them out to the outside world, the FX3. Any more questions? Oh, I went the wrong way. Sorry about that. This compares with the, this is the block diagram of what you had in RASDAR 2 and RASDAR 3. It had a single channel transmit and single channel receive. I won't dwell on it very much. But it had that kind of architecture. And about the same size, this is what you got on the 7002 chip. Everything is reduced in size inside the chip and outside the chip. It has 2 of each, 2 of everything up in the line, transmit, receive, and it has double interfaces to the world. Just a double receiver. This is a block diagram functionally. These LEDs are nice to have. They do what they are on the front panel. They are 2 little holes you saw, if you saw that run going around. They're on the front panel. One of the things we want to do tonight, which we're getting help from Mr. Skip, is going to work with me because I set it up with Sue Ann. We're going to do RFI testing on this box that's not in it. And we're going to put it in the garbage can. If you were here a few years ago, we showed us the garbage can. Where you, it's a, I can't say it right, isotonic chamber, is that the right word for it? Anaconic chamber, that's it, that's the right word. And they can measure what's in there, so we'll see what we have RF linkage in. We're going to do that tonight, I think, or tomorrow night, one or two. Because they got the equipment here, and they got the garbage cans, right antennas in it, things like that. So what do we want to do, as Skip says, you'll have the, if you pass this Part 15 test, is what you're going to look at it, you'll have the best SDR in the market as far as marketability. And we're hoping to, because both these have very good sealed joints. They're tongue and groove joints on the side. Right? A little tongue that sits in the groove. They all have, nice tight fitting covers on the ends, and they're well built out of extruded aluminum. All right. It has some DDR2 RAM, which I don't know if we're going to use, but we might. Got 8 double EEPROMs. Double EEPROMs provide the software, firmware space for the FPGA and for the FX3. I think there's 2 sets of them somewhere. That's called configuration flash. This one's for the FX3 chip, and this is for the FPGA. The FPGA is programmable with the utility that they give you with it from Alteria, Cyclone 4 FPGA. The FX3 is programmable from Cypress type equipment, and Tom will appreciate this. We're not using any drivers other than Cypress drivers. We're not going to get into a 6-month issue or 6-month, 12-month issue of trying to make compatible drivers with our own name on it for no reason. Because we're not building the boards, Lime is. Lime has a responsibility to name that driver, we don't. And they're using Cypress off-the-shelf drivers. That's what we're gonna use. You agree, Tom? Since you were involved in that, that's 6 months development time we don't need to take out of. So you can go on the web and go to Cypress site and download the FX3 driver, plug the board in, and you can set it up in your system so you've got a driver connected and it will work. Okay. No need to invent something that's already invented. Wrong direction. This is the eye chart, which is very important to look at. It's in the book if you want to look more closely. But the key is over here in this column. You can change that to say Raspberry 4 up there, because it is an LMS, a line SDR board with a box on it and some cables we had to. And the price is right now $289, not $299. Originally they were selling them for $199 and then $249 for the second block, and now it's $289. And the CEO of Lime says he's going to hold that for a year. And if it sells enough units to keep his production line going, he's going to keep it there. Okay. He's looking at it as, what can I sell, what can I, price it accordingly. I think he'll keep it there, because 1,500 users in a few months is very fast. You get that many users signed up. It compares with the EDIS products, the Hack RF, the Blade RF, the RGL SDR, and the Lime SDR. The one that's closest to Raspberry 2 is the Blade RF. It's the closest functionally and price-wise. We didn't ever sell any, so we don't know what the price is. And we're going to add to this probably $75. We'll get to it in a minute to put a box in it. If you want it. You don't have to buy the box. You don't have to buy anything. But if you want our box and like our box, about $75, and the software will come with it. Okay. Inside the box, there is also a temperature sensor on the board, which was very handy. So one of the first things I did was to say, well, if I'm going to build a box, can I keep it cool enough that it won't burn itself up, particularly during this meeting? So I ran some heat tests on it. And the results on the red line are what I ran, and the results on the yellow line are what David had decided it would be if you had a different ambient room temperature. Right? So I ran it at my room temperature, which was about 28 C, in the basement of my house. And I went through different steps of powering on and watching the temperature rise, and then loading the configuration files, which sets up the configuration, and then going through and starting to record FFTs, and eventually it levels up, stabilizes at about 45, 46 degrees C. The belief is that 55 degrees C is the limit, because there is also built in a switch that works on this temperature sensor, that if you want to equip it with a fan, the switch will operate at 55 degrees C on and 45 degrees C off. And that's in their spec of what it's supposed to operate at. And we've got the question into to Lime, and they haven't answered it yet, but that's not unusual. They got a lot to do right now. Is 55 degrees C a good limit? And I believe it is. If you're going to turn the fan on for the first time there, if you can hold it below that, great. So my judgment is that you should probably be able to operate with an ambient room temperature. If I was 28, maybe 38 ambient temperature or something like that. Not 38. Look at David. Well, he did the green was 38. Should be able to operate probably in between, so about 30 something, 34. Don't put it out in the sun, you don't need a fan. Put it in the sun, you better get a fan. Right? Or get some convection vents on the outside of the case or something more elaborate than a simple case. Got any questions on heat before I go on? That's about all we'll talk about. But it looks like it'll run ambient room temperatures, reasonable indoor temperatures without cooling. Everything is open source with Lime. Their software that is available now with a grain of salt is LMS 7 Suite. All right, LMS 7 Suite is a combination of Linux and Windows. You can get either version available. They would like you to compile it in on Linux, and they'll give you an exec on Windows if you want it, which is what I got, with a little bit of difficulty in transmission of execs through the network, right, that we know about right now. But we got it, and that's what I'm running on, is their compiled exec. It has all the setup stuff in it. It has a control of more than you ever care to know about in terms of the options you can use on the system. It has utility capabilities for loading firmware, reading temperature, setting frequency reference, and obtaining a lock from the frequency reference, and a lot of other stuff. It has FFT viewer built in, and has I versus Q display like the FFT viewer did before, and a FFT display. 2 channels on everything though. You can use A, B, or A and B when you get a selection of.
Just slide left intentionally blank.
What? Other software. And I'm willing to take anybody who wants to volunteer and investigate all these, right? Because I don't want to do that. Right? I'm going to modify LMS 7 viewer to work on Windows for radio astronomy. But if anybody wants to take on GNU Radio, MATLAB, SOAPy SDR, I don't even know what SOAPy stands for, but I think it stands for Python on the last 2 digits, I think. Right? And if anybody wants to take on that and say, what can you do with it? Ubuntu, which is a Linux standard of sorts, and UHD API. I don't even know what that is. The API, I understand. That's a whatever programming interface. They all will work with it, quote, and I say with a big quote, untested. There's people working on them. There's a guy that's a very strong Linux guy that's keeps bringing up stuff that make it work. But there's others that haven't. So let's take a look at what it does. This is an example with the back part is a setup screen of one of them, one of many. And then the right part of it is a view of a dual channel FFT and dual channel IQ samples, dual channel I versus Q. I versus Q, if you're into QAM at all, is a constellation chart. It shows you where the zeros and ones are landing on the constellation of phase and power level relationship of the I and the Q rep. Right? It's useful for that. It's also useful to know that you've got them balanced. It should be a circle or a good facsimile of a circle. And the IQ samples is good for level adjustment, but it's telling you how far are those I and Q samples deviating from 0. If you give them too high, up to around 2300, you're going to start clipping. If you give them too low, you don't have enough signal to drive it. That's a simple explanation. Down below you see the 2 FFTs. I offset them by 10 dB so they wouldn't be on top of each other. So that's why you see the red and the blue that are different. If you, I talked earlier about the decimated AAA. This is the chart that I'm most proud of in terms of what I did in 3 weeks. In 3 weeks I was able to prove how to do that, talk Lyme into telling me how to do it, and do it. which was an amazing feat, because they didn't even know hardly what I was talking about with the people I was dealing with. Our good old friends of, Zydrunas and, what's his name, Ricardus?
Well, this is being streamed. I would be more,
Okay.
don't say that.
Anyway, they're good folks, they helped a lot, but it took a little bit to get there. And we got to the point where I learned how to set the decimation ratio on the chip, which you have to set, and you have to turn it on. And once you turn it on, you put in 61.44 megasamples per second on the front end, and you get out on the back, what does it say up in the right-hand corner? 960 kilohertz or something like that. That it's decimated it down. It's improved the signal-to-noise ratio accordingly. And my signal generator of the tone at 1.197 or whatever, the one that's standing up all by itself, is at minus 133 dBm. If you know anything about receivers, that's below your normal noise floor. Your normal noise floor is about 130 maybe if you got a good receiver.
What's the bandwidth on the bin?
The bandwidth on the bin is, and you can calculate it on here, it's setting at about 409, I can't read that without my glasses. I'll read it off here, it's easier. It's 4096 samples per frame, and it's running at 0.94 samples per second, or 96, whatever that is up there. If you divide those two, that's the bandwidth on the bin, which would be 0.9 divided by 4,000, a few hertz, I think. Maybe I got a calculator handy. There's no who can do that in their head. 0.9 divided by 4,000. Be about 5 kilohertz. How's that sound? About.
Too low.
Hmm? Somebody said something?
Yeah, isn't that too low?
What do you mean too low? Who's talking? I can't recognize. Oh, right there. It's maybe too low. No, I don't think so. I wish we had Carl here, but I think he uses 10 kilohertz bin widths in his, and has been very successful at it. Tom knows, but he isn't here either. Does anybody know? You can set it. Change it. You want it wider? Don't decimate quite as much. And the key is that, boy, did that make a nice looking identification of that. See, I've got about 4 or 5 dB more I could go. And still, if I was really glancing at it straight, I might be able to see it out of the noise. But seeing it out of the noise this well at 133, I think is pretty darn good. Raster 4 Viewer will be our software. We'll improve it, simplify it. Still use LMS7 setup capabilities. I'll probably call on their modules just like I did before. In other words, if they want to set frequency, instead of about a 5 or 6 stroke switching screens twice type of operation, there'll be one. Set the frequency, hit the apply. Right? Is the way I'll set it up. Specific features for radio astronomy, like continuum measurements. I may use RSSI if you're familiar with cellular or even mobile radio. RSSI is a built-in capability of received signal strength indicator. It's what makes your bars go up when you look at it. Okay, and I may use that as a continuum measurement. I don't know yet for sure, but it's there, and I could pull it real quickly. And it's calculated the right way. It's using complex I and Q, it calculates it by squaring the I and the Q and that you need to do, and dividing it by a constant. Expected release November 30th. We want it to be there when the boards come out. or right around there, Christmas present. Right? Now, I don't guarantee that everything that will be ready to go November 30th, but I guarantee we'll have something ready to go November 30th. Obtaining one. How do you get one? You order it. You get in line now. You pay $289 to Lime when they ask for it. And you'll get a board in the mail sometime probably after November 30th now, because I think they probably sold out all the early ones. You're in the queue. Order a kit, somewhat less than $75, I think. The key question is, what does it cost for UFL to SMA cables and bulkheads? If I can buy them from, if I put 4 of them in it, I can buy them from Mauser or DigiKey for probably about $59 total cost, and a little less than that, probably $48 for the cables and the connectors. And we can get them on eBay, take hit or miss if they happen to be there, for less than that, for probably $4 or $5 a cable. And we really need a good source of cables. I'm a little bit reluctant to do eBay source unless it's from a manufacturer. If it's a kid with a soldering iron who tried to solder these cables together, no. Right? If they're good factory-made connectors, it'll be fine. Okay, you need a USB 3 A-to-A extension. You can order it with the B connector instead of the A connector. Don't, right? Don't do that. It hurts. Ouch. The type B connector is micro B, is real small, and it has, you know about it too, Charles. You can fix some of those. It has enough leverage on the cable that you can pull the connector off the board. All right? Just by moving it around, just by taking the cable and plugging it into another computer, I've taken them off the board. And Bogdan and Charles have both put some back, right? So buy the Type A, they're strong, sturdy. The USB extension cable, I bought mine at Fry's. You can buy it online for about $13 and something. And I got a 10-foot one, so I wouldn't have to ever worry about not having enough cable. And it still meets USB 3.0 spec. So it's got the shielding in it, and the gauge of the wires are such that it meets USB 3 spec. Total cost probably $364 to $377, whether you need the USB 3 cable or not. I think that's about it. So, no, wait a minute. What do you get in the kits? You get from the Crowd Supply or Lime, you get a board, you get a flash USB drive, documentation, USB driver firmware, and LMS7 suite software, and others. I don't know exactly what all they're going to package on it, but others. Some of that other Atlantic stuff I mentioned is probably on the chip, on the driver. What do you get in the Raspberry kit? We're thinking of having the aluminum enclosure, hardware, 4 coax cables with UFL, USB, bulkheads, a flash drive. I thought about, we put some stuff out on CDs, but I thought about it. CDs are turning to atrophy on some computers. They aren't there anymore. Right? If we're going to put a USB device on it, you got to have a USB port, so you can read a flash drive. And I found some for $3 and something a piece, or $2.30 or something like that, in bulk kind of quantities, and that's a reasonable price to pay for distributing software. And documentation. David says he's going to continue with the user guides, and we'll work at it, and other people volunteered already. We have written our first section, which if anybody wants to read it, I'd be glad to share it with them. First section is called Assembling the Case. What do you have to do to put it together? And the key ingredients are screwdriver, and be able to hit a little number 1 or number 2 screws. And so you might want the needle nose pliers and be able to plug the UFL cables into the board. that is the hardest task, incidentally, is to get them to snap. They snap in like a little snap on a shirt collar, except it's smaller than the shirt collar snap. You mentioned that you can get an extractor.
There's an extractor, and making a comment, because you use it for, make sure you put them on squares, straight on.
Straight on, yes.
Yes, and this extractor is a little hook, two hooks that pull straight off. But they use them in laptops by the zillion for all the
Right.
antenna connections. So it's a reliable connector, it works well, and it's small.
It's very small, and it's reliable. The only thing is, it has 15 insertions is its rating.
Yeah, 15 to 100 is pretty
15 to 100, okay. That's my expert over there on UFLs. So that's another maybe $5 to $10 you might have to pay if you broke one of them. Because you got to buy a new cable and probably the SMA connector with it. Any other things? I think we're about done. Oh, scheduled delivery November 30th for everything, we hope. And that's the talk. Some more questions, comments? Yes, go ahead.
You mentioned the possibility of expansion board and looking
Right.
at other options in the future.
Right?
That case is really tiny.
About half full or less.
What's that?
About half full or less. Maybe I should take the cover off. Let me take the cover off of.
So you think there'd be room to add an expansion board?
There is room to add an expansion board, absolutely. See which one's the top one is. Somebody take this apart. It's got, I can keep talking. That's just a blank one. Don't lose the little black screws. The way the case is laid out, and it's you could actually buy this if you want them at Fry's. They sell them if you know about Fry's Electronics. If you happen to be lucky enough to have a city like Atlanta that has at least two Fry's, one over by where Charles lives and one by where I live, right? That you can go down and buy them off the shelf. If not, order them online, www.frys.com. Right? And the model number of the case is a 2506. Right? 25 means it's 2.5 inches wide inside on the slots, and 06 means there's 6 slots in it. Right? There's 6 different places you can slide a board into it. It is exactly 2.5 inches wide. Right? There, he's got it apart. That's good enough. One end is good.